Hello and welcome back to Cybersecurity Matters, the place where we unravel the complexities of cybersecurity. I'm your host, Sylvia. Today we are continuing our deep dive into the bot management series. Last time we talked a lot about CAPTCHA harvesting, and in this episode we're moving on to explore image model-based cracking. Joining us again is Wenchao, Product Manager at GeeTest. Wenchao, welcome back.
Thanks, Sylvia. It's great to be back. I'm looking forward to explore image model-based cracking with you and our listeners.
Alright, Wenchao, let's bridge the gap between our last discussion and today's topic. We've covered CAPTCHA harvesting in depth, but now we are facing a newer challenge, AI model-based cracking. Can you explain why this evolution is significant and how it differs from traditional cracking methods?
Well, think of it like moving from handcrafting to automated mass production. That's what's happening in CAPTCHA cracking. In CAPTCHA harvesting, the process was manual and labor-intensive. Attackers had to collect and solve each CAPTCHA by hand or with basic scripts. Now, with image model-based cracking, it's as if they've switched to using highly sophisticated automated systems. They are deploying advanced algorithms and machine learning techniques, creating a digital brain that operates much faster and more efficiently than any human.
So this represents a significant technological leap for attackers, right?
Certainly, the key lies in adaptability. With manual methods, each update to the CAPTCHA system reduced their effectiveness. But now, using AI and machine learning, attackers have developed adaptive models. These models are so agile and well-tuned that they can swiftly adapt to new CAPTCHA designs, retaining high accuracy unless there is a major overhaul in CAPTCHA's structure.
It's evident that threat actors are really leveraging these advanced tools to bypass cybersecurity measures. So, Wenchao, can you get us through the specific process attackers use for automated CAPTCHA solving? What are the key steps involved?
It begins with targeting, say, a gaming website. Attackers initiate repeated login attempts, each time triggering a new CAPTCHA challenge. They collect these CAPTCHA image addresses and save these images in bulk, forming the basis of their operation.
So the initial stage is all about flooding the system to harvest a batch of these CAPTCHA images. What's their strategy after gathering these images?
Once they've amassed a large set of CAPTCHA images, they move on to the construction of models. Each CAPTCHA is labeled with its correct answer, aiding the dataset for the training phase. Here, convolutional neural networks or CNNs play a critical role. They are the backbone of these AI image recognition models due to their exceptional capability to cipher intricate details within the CAPTCHAs.
Wow, they seem to have found the right technology for this task. Speaking of these models, what types do they typically construct for CAPTCHA solving?
There are two primary types they rely on: classification and similarity models. Classification models are trained to identify the position and the category of each icon in the CAPTCHA. Meanwhile, similarity models focus on comparing the CAPTCHA's prompts with its icons to find the match and determine the correct sequence for solving.
Classification models, similarity models, they seem quite sophisticated. How do they function with specific types of CAPTCHAs like GeeTest icon CAPTCHA?
In GeeTest icon CAPTCHA, which requires selecting icons in a particular sequence, classification models are designed to determine the position of icon within the CAPTCHA and classify both the target icons and prompts. Similarity models calculate how closely the icons match the prompts, determining the order in which the user should select them. They are not categorizing icons but rather matching them based on their similarity scores. If the CAPTCHA prompt shows Click the train, then the car, then the book. The model uses similarity scores to match the prompt icon and target icon, and then determines disorder.
That is a clever strategy. Besides these modeling techniques, are there other strategies attackers use to boost their success rate?
Yes, another key technique is object detection. This method is particularly cost-effective for CAPTCHAs that require a specific clicking sequence. Object detection techniques ascertain the exact location of each icon. With this special information, attackers apply enumeration methods to systematically determine the click order. In a CAPTCHA with 3 icons, for example, they can find the right sequence in just 6 tries, given the limited possible combination.
It seems there's a great deal of thought and precision in this approach.
It is. It's not just about brute force. It's about leveraging sophisticated models and techniques to bypass CAPTCHA. By continuously refining their models, attackers maintain their effectiveness against new CAPTCHA updates.
This obviously presents a major challenge for CAPTCHA providers and online platforms alike.
Indeed, the motives for attackers vary. Some are in need for financial gain, automating tasks like creating fake accounts, while others enjoy the challenge or aim to disrupt service. But overall, CAPTCHA cracking has become both lucrative and intellectually challenging endeavor.
Wenchao, shifting gears from our technical discussion, let's revisit something we touched on in our last episode. We talked about the economics of CAPTCHA harvesting, like how updating a batch of 300,000 images costs around $630 and over 200 hours of manual labor. And with the automated techniques you described, how does this economic landscape shift?
Well, the move to automation significantly changes the game for attackers. The initial collection of CAPTCHA images still takes about 8.33 hours, but what follows is a drastic improvement in efficiency. These sophisticated techniques dramatically reduce both time and cost for bypassing CAPTCHAs.
So we are looking at a substantial leap in efficiency?
Exactly. The efficiency with automated models increased by at least 25 times. The initial setup of these models is one of investment. After that, they effectively handle new CAPTCHA challenges, even with image set updates, as long as the core elements remain consistent.
Wow, a 25-fold increase in efficiency is staggering. This transformation in attack methods must have significant implications for businesses trying to protect themselves. So, when can you share how companies like the gaming ones you mentioned experience and identify these automated image recognition attacks?
Absolutely. Let's take the example of Company H, a client of GeeTest. On a typical morning, our team noticed an unusual surge in CAPTCHA requests for Company H, almost 30,000 interactions per hour. This was our first clue that something was missed.
That's definitely out of the ordinary. Given the sensitivity of gaming companies to unusual traffic, what measures did Company H implement in response to this attacking pattern?
Company H was quick to act. They already had CAPTCHAs deployed as a defense against brute force methods. However, by afternoon, we observed another wave of CAPTCHA requests. It was clear the attackers were harvesting these CAPTCHAs. We immediately implemented a dynamic image set update, which temporarily disrupted their tactics.
But I assume the battle didn't end there.
Exactly. The very next day, there was another surge in activity. This time, the evidence suggested that the attackers had upgraded to sophisticated image recognition models. This was clear from the rapid rate of CAPTCHA requests and the consistency in the answers they were generating. They were successful in about half of their attempts, which was concerning for each company.
Similar to what we've seen with capture harvesting, for businesses facing these threats, how can they tell apart different types of attackers?
It's about analyzing the patterns. If an update to the CAPTCHA image set stops the attack, it's likely a harvesting-based attack. But if the attack picks up again soon after an update, it's likely automated model-based cracking. Employing strategies like visual deception and changing icon styles can effectively counter these more advanced techniques.
It sounds like security companies constantly evolve their strategies to combat emerging threats. Wenchao, can you provide a tangible example of such a tactic? How do security vendors like GeeTest use techniques like visual distortion to outsmart these automated systems?
Absolutely. Both humans and automated models can fall prey to visual biases. An everyday example of this is the Ames room illusion, famously used in The Lord of the Rings. In this illusion, two people appear to be a vastly different size due to the room's trapezoidal shape, although they are actually the same height.
Oh, I remember that. It's quite a mind-bending illusion.
Exactly. The room's trapezoidal shape, when viewed from a specific angle, creates this size distortion. The person who appears smaller is actually farther away than the larger one. We employ a similar principle in our captchas. By manipulating visual elements, we create scenarios where automated models are tricked, much like the human eye is with the Ames room.
So you are essentially using optical illusions in captures to deceive these automated cracking systems?
Yes, we introduced complex patterns and designs, like honeycomb pattern, where real icons were wrapped in intricate patterns. This design is easily decipherable by humans, but presents a significant challenge to automated models.
That sounds like a smart way to leverage human visual capabilities against machines. How does GTest incorporate these tactics into practice?
We implement various visual deception techniques in our icon captures. The honeycomb pattern is just one example. These patterns create a visual labyrinth, making it tricky for automated model to locate and match the icon correctly. The models might see the icons, but the additional visual layers disrupt their ability to process and respond accurately.
Intriguing. So it's like turning captcha into a visual puzzle that's easy for humans but baffling for machines.
That's the idea. It's all about creating a visual conundrum that automated systems can't decipher. This approach not only bolsters security, but also adds an element of fun for users. In addition to honeycomb designs, we use various other visual manipulations to keep this system guessing and ensure they can't adapt easily.
It's a creative way to stay ahead of attackers. Do these visual tricks pose any challenge to regular users?
Not at all. We carefully design these captchas to ensure they remain user-friendly. While they are complex for automated systems, they are intuitive and easily solvable for humans. This balance is the key to effective CAPTCHA designs.
And did this strategy prove effective for Complete Edge?
Absolutely. Implementing these updates in real time took the attackers by surprise. Their success rate in bypassing the CAPTCHAs dropped dramatically, indicating their inability to adapt to our updates. Essentially, we reset their progress, forcing them to start over with new model training. The process that's both time and resource intensive.
Alongside visual deception, what other innovative defenses does GeeTest use to stay ahead of cyber threats?
At GeeTest, we pride ourselves on blending technological innovation with creative solutions. One area we've excelled in is using AIGC. This involves crafting CAPTCHA designs that are visually complex yet intuitive for humans.
It's really a fascinating dive into GeeTest's world of cyber defense strategies. For those eager to dig deeper into this realm, perhaps get a first-hand look at some real-life cyber battles and better understand cybersecurity basics. Where can they find more, Wenchao?
I'd definitely recommend our Boat Management 101 ebook for everyone interested in exploring further. It's packed with comprehensive strategies, defensive examples of our CAPTCHA solutions, and insightful perspectives on the ever-evolving cyber threat landscape.
Thanks, Wenchao, for shedding light on all this today. It's been super informative. And for listeners, I'll make sure to include the download link to the Bot Management 101 ebook in the summary for easy access. And with that, we're wrapping up another episode of Cybersecurity Matters. Big thanks to all of you for tuning in and diving into these complex cyber topics with us. Today's chat really underscores the need to stay one step ahead in the cybersecurity game. If you are curious to get more insights into GeeTest strategies or just want to expand your cybersecurity knowledge, don't forget to check out Bot Management 101 ebook linked in our summary, or visit GeeTest.com for more resources. If you love the show, please follow us on Spotify, Google Podcasts, or wherever you tune into your podcasts. We are excited to bring you more enlightening discussions in our future episodes. Until then,